Okay, out of the four topics which have been shown in the introduction part, first topic which we are going to deal is cell. What it is? Cell. Cell in a term in layman language it is battery, which you have seen in your daily life. What does it contain? It has one positive and negative terminal, right? So when you are asking a common person what a cell is or what a battery is, you will say something or a device which is used for boosting up, right, or to give energy to a circuit. Without it, a circuit is not going to function, right? Now the cells, what is the basic symbol of cell? Right, two parallel lines, one is big, one is large, or one is big, one is small. If they are both of same size, becomes what? Capacitor. Right. Now, what is the basic function of cell in terms of your physics, which you have to understand properly? Then only you can go further to the next of the topic. So, first function of the cell is it is a device which provides electrical energy to all the components of a circuit. Suppose this cell, if I am connecting to a resistor, right, positive, negative, then this cell provides energy to the all the components. What component is here? This component is just a resistor. So this cell gives energy to this component, that is resistor, right? That is its first function, right? And that is the first specialty of it. Now the second specialty is it do not produce charge. Does it produce charge? No. It just forces the charges which is already present in the wire and the components to move about in the complete circuit. Right? It doesn't produce any charge. It just it just moves the electrons inside the conductor, right, by giving energy to those electrons. Or I can say the third major function of a cell is it maintains a potential difference, right? It maintains a potential difference across the terminals of the component, so that due to this potential difference only the electron flows inside that component, and due to that electron flow only the current is coming. Right, I hope you understood. So what are the major three functions or what the specialties of a cell are? First, it is a device which provides electrical energy to components of all the circuit. Second, it do not produce charge. It just moves the electron inside the conductor by giving those electrons its own energy. Now, and third is it maintains a potential difference which forces the electron to move in the circuit, and the electrons moves from higher potential to lower potential. This much clear? Now let's move on with how the chemistry of the cell is. Right, most of you guys might have learned this portion in electrochemistry and chemistry. Suppose how would I draw what do you mean by an electrochemical cell that you had learned in chemistry? What is an electrochemical cell? Electrochemical cell is a cell which converts chemical energy to electrical energy, right? So what and all are the basic parts of an electrochemical cells? Suppose I consider a container like this. It will be filled with a liquid section that is known as electrolyte, right? There will be electrolyte, right, and it is a conducting solution. Now inside that there will be two metal plates, and we call it as what? Electrodes, right? There's metallic plates, and they will be connected. When you connect to an external circuit, it will be like this. Out of this, one rod will be cathode and the other will be anode, right? And what is the basic process which is happening in an electrochemical cells? It is exothermic. These and all are chemistry portion, but I want to take this section, exothermic redox reactions. So what do you mean by exothermic? The type of reactions in which energy is released. And what do you mean by redox reaction? The type of reactions in which both oxidation and reduction happens. That means inside the electrochemical cell, energy is going to be released, right? Similarly, one bar will be undergoing oxidation and the other bar will be undergoing what? Reduction. So these three, or I will say these two sections, contribute to the entire function of a electrochemical cell. Right. In order to understand the entire working of cell, let's move on with an example with a lead acid battery. Right. So I'm going to draw a diagram again, guys. Suppose I'm going to consider this is a container, and I'm going to consider two bars metallic electrodes, right? So this is PbO2, lead dioxide, and this bar is just lead, right? And the electrolyte inside is dilute sulfuric acid, H2SO4, right? Now I have not connected anything. This is not connected to an external circuit. This entire cell is now idle. It has just started. I have just dipped these two metals inside this dilute H2SO4. Now dilute H2SO4 is having two sections, right? It is having H plus ions and SO4 2 minus, right? So 2 H plus ions and SO4 2 minus ion are constituted in H2SO4. So H2 plus ions, what they when they split, they become what? Suppose I will write here 2H plus and SO4 2 minus. This 2H plus ions can react with lead oxide of this metal, right? That is H plus ion. Suppose I consider only one H plus ion, it releases the electron, right? How it releases the electron from what? PbO2. That is PbO2 will give one electron to one H plus ion, so that it now converts to what? H, right? That H is known as nascent hydrogen. What it is called? Nascent hydrogen. Let me repeat. Dilute H2SO4 segregates into two parts, 2H plus and SO4 2 minus. If I consider only one H plus ion that accepts an electron from PbO2, hence H plus becomes what? H plus, when it receives one electron, it becomes H, right? This H is known as nascent hydrogen atom. Clear? So there are two H plus, means it will be accepting two electrons, then that is known as what? Two nascent hydrogen atom. I hope this is clear, right? So as soon as the electrons are lost from PbO2, what charges will be PbO2 getting? If it is losing electron, 2 electron lost means now PbO2 is having 2 positive charge. Electron is lost, so now PbO2 is positively charged. This much is clear, right? Now we say how the exact equation is, or what is reaction happening in that section. That is PbO2, right? It is reacting with, now PbO2 is there, H plus has released or accepted electron from PbO2 and it has become nascent hydrogen, right? So PbO2 now reacts with this nascent hydrogen and it gives PbO, lead oxide, plus H2O, right? Now this lead oxide is highly reactive, it is not stable. So what PbO do? It reacts with H2SO4, giving PbSO4 plus water. Clear? Now what is the net? I can add these two reactions. We can say what is the total reaction happening inside the battery cell. That is PbO2 plus 2H plus H2SO4 gives PbSO4 plus 2H2O. This is the actual reaction which is happening inside the cell when you compare or when you consider only this section. Yeah, this and all you can understand from the chemistry section. This is not important in the terms of physics. We'll deal with physics now, right? I'm just giving the equations. Guys, this much portion, that is this and all reactions, I'm just telling you, these sections need not be mentioned during your examination or your study. You just have to understand it is an electrochemical cell which is having exothermic redox reaction. One bar will be undergoing what? Oxidation, other will be undergoing reduction. This much should be clear, right? Now let's move on to the second bar, that is lead bar. Now we are having H2 plus, we have told what is going to happen. Now we will deal with SO4 2 minus. Now SO4 ion reacts with the lead plate, right? When lead it is reacting means it is giving electrons here, right? It is providing electrons to lead, so that this lead plate now goes to become negatively charged, right? I hope it is clear. That is, in the end you can say PbO2 is getting 2 plus charge ions, whereas lead is having 2 negative charge. This way, now suppose this reaction is going to continue As the continuation goes on, the charge accumulation increases in PbO2 and Pb. That is, PbO2 becomes more and more positively charged and Pb becomes more and more negatively charged. Right, till there is a position or there is a point that which increases more and more till positive charge in PbO2 becomes too high, that now the H plus ion, when it is seeing, it reaches here, no, it tries to accept electron. At that time it sees that PbO2 is full of plus charge, so H plus is already plus charge, so they will undergo repulsion. So now the H plus ion can never go near to highly positively charged PbO2. Right, I hope it is clear. That is, it is repelled by the positive charged PbO2 metal plate. That is, there is an electrostatic repulsion. Thus, there will not be further reaction which is going to happen now. Similarly, now Pb is fully negatively charged. SO4 minus try to go close to Pb or lead plate, but lead is negatively charged, negative repulsion, so SO4 minus can never further react with lead, hence the reaction stops there itself. So that means high positive charge accumulation in PbO2, high negative charge in Pb, plus charge high, negative charge high. That means I can say there is a potential difference or a maximum potential difference between these two plates. I hope it is clear. Right, so that position has been now reached, and I will say now the cell is ready, right, to give charge or can be connected to any other device. I hope it is clear. Right, now that is maximum, or the potential difference is now maximum, that it doesn't charge any further. This is what happened when electrochemical cell is considered. Clear? Now we will deal with now this positive charge, negative charge accumulation should be understood, guys. This is what we are going to carry forward further. Right, now suppose I am going to consider a figure again, guys. Suppose I am going to consider an electrochemical cell. Right, this is right. Now I am going to say this section is fully negatively charged, this section is now positively charged. That means this is your PbO2, this is your Pb. This much clear now, and that means it is having negative potential. That will deal later on. Suppose this is your cell, this is your electrolyte. You are having electrolyte here, electrolyte, and okay, which is anode and which is cathode, guys? Positively sectioned, right? So this is your cathode, this is your anode. I hope this much is clear. Cathode is a place where the oxidation is happening. Anode is a place where reduction is happening. This much section I need not learn or teach you, guys. You have studied in electrochemistry. Right. Now suppose in this scenario, let the maximum potential of anode be minus V and that of positive or your cathode be plus V. That is the maximum potential they have achieved. Now what happens is, what happens if I have not connected something, right? I have not connected any external circuit. Now I am going to connect, I will take another color. I am going to connect an external circuit. Let it be resistance R, right? External circuit has been connected here. Now what process is going to happen? We are going to deal with that. Clear?